Hello everyone, today we're looking at an introduction to Venn diagrams, and we're going to start by just looking at a Venn diagram in front of us regarding students in class 2A that play tennis and golf, and then we're also going to link it to notation associated to Venn diagrams, and then finally end with some questions on probability and just how to fill in a Venn diagram ourselves. So when we look at this diagram in front of us, our Venn diagram has a few specific key things. It's got all of these students which are in class A. We have 7 over here, 8 over here, 5 over here, and 4 over here. And whenever I refer to a Venn diagram, we basically say that you've got two circles. One circle on the left represents everyone that plays tennis, and the circle on the right represents everyone that plays golf. Now, the number outside refers to people that do neither but are still in class 2A. And the number in the middle refers to those people that do both of those things, which is why there is an overlap. So if I was to say how many students here play tennis, it's going to be one of these numbers below. Now, a lot of people might say 7. The number of people that play tennis is actually the 7 plus these 8 people as well, because they play tennis as well, which makes 15. So actually 15 people play tennis. Now we look at the people that play golf. Well, we can say the people that play golf, again, are not just the 5, but the 5 and the 8, making 13. So we can put under here, this is golf. Then we come to those people that play both tennis and golf. Well, the people that play both tennis and golf is the 8 in the middle. So over here we can write tennis and golf. Now we've got a few other numbers here. We've got the 4. Well, 4 we said play neither, so I'm just going to put a big N under that. 4 people play neither tennis nor golf. And then we look at the value of 5, 7, and 20. Well, 5 are the people that play only golf. So I'm going to put that as only G. 7 people play only tennis. So again, I'm going to put only tennis over here. And the 20 represent people that play either or play tennis or golf. So any people that play tennis or golf. So this would be tennis or golf. So those are kind of key values which we've come across. Now, this is all about the students in class 2A. If I asked you about questions about students in class 2B, I couldn't use this Venn diagram. And this is referred to by this symbol here. It refers to the universal set. So right now we're going to look at the key notation when we look at Venn diagrams. So I'm just going to move this across over to here and move our other board over here. So we're going to look at the key notation over here. So we said this represents the universal set, which effectively is what the title is. The universal set are all the students in class 2A. And then we've got a few things we need to shade in. Now, over here, I've got a Venn diagram for A and B, A and B, A and B, A and B. Now, the first one says, what is A? Well, A is everything inside of A, very simply. So I can just shade in that anything referring to A is all the people in A. So for example, over here, tennis is all the people inside the T. We then have what we call A dash, or the complement of A, which means everything outside of A. So anything that is not inside A. Now I'm going to shade in a bit of B, but not the overlap, not this intersection, because that is still in A. So we call that the complement of A, but effectively it just means everything not in A. Now we've got this symbol AUB. Now AUB means the union. When we talk about a union, it means everything inside A and B. And then you've got ANB, which refers to what we call the intersection over here, the intersection of A and B, which is just this middle bit. So effectively, the way we think of the intersection is if we shaded in A and shaded in B, which bits would have both parts shaded. So we're going to look at a few of these over here on our Venn diagram. We're just going to shade in the bits which are required and look at the value inside. So TUG is the union, so everything inside T and G. So T union G represents the numbers 7, 8, and 5. That is equal to 20. That was that value over here. Now, the next one is T intersection G with a dash. Well, T intersection G just means the middle bit, the value of 8. But a dash means everything except that. So that means it's everything except that 8. So the way I'm going to show that is I'm going to shade in everything outside of the intersection. So we can see it's actually the 7, the 5, and the 4. That's 7 plus 5 is 12, plus 4 is equal to 16. Now, the last one is a bit tricky, but it's actually linked to what we have before. This is the same. We've got TUG, which is this over here, and the intersection with TNG dash. So we're looking at where these two things intersect. So i.e. which of those bits are shaded together? Well, the outside bit is shaded here, but not here. The middle bit is shaded here, but not here. But these two outer bits, the 7 and the 5, are shaded in both. So actually, we're just looking at these parts over here, which is the 7 and the 5, which equals to 12. So there we've got shading, and that's kind of our key introduction to shading, just using these key rules. Now, we did say we're going to look at probability. So if I said, coming back to over here, the probability of A is equal to the total number of elements in A, so the number of elements in A out of the total number of elements in the universal set, so inside here. So if we bring this just back to this over here, if I said what is the probability of picking someone from random of this class and getting T union G, so probability of T union G is the number of people or number of elements in T union G, which is the 7, 8, 5, which is 20. And we divide that by the total number of elements in the universal set. So in the universal set, there is 7, 8, 5, and 4. So that makes 20 out of 24, because there were 24 people I could have chosen from. Now we can leave it like that, but it's better probably to simplify. We simplified by dividing both by 4, we get 5 over 6. If I said the probability of T intersection G dash, it would have been 16 out of 24. And the probability of this one over here would have been 12 out of 24. So that's how we look at probability within a Venn diagram. Now, we're going to link it to one other Venn diagram, which we're going to fill in together. And then we're going to call that a day after looking at the probability within that as well. So over here, I'm going to turn this over and have a very, very simple probability, which we're going to fill in together. Now it says the universal set in this case are the numbers from 1 to 10. So numbers from 1 to 10 are all the numbers that are going to go into this Venn diagram. So I'm going to write them underneath. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we've got two categories. We've got odd and prime. So for odd numbers, I'm just going to underline in red. So 1, 3, 5, 7, 9. We're then going to look at the prime numbers. Now, the first prime number is actually 2. It's not 1. 2 is the first prime number because that has two factors, 2 and 1. This has two factors, 3 and 1. This doesn't have two factors. It's got 1, 4, and 2. 5 is prime. 6 isn't prime. 7 is prime. 8 isn't prime, 9 isn't prime, and 10 isn't prime. So when we look at this, the values that are both odd and prime are 3, 5, and 7. So I'm going to put those in the middle. 3, 5, and 7. Now the number of the other ones which are odd in this case, which we can put in, are 1, or only 1 actually. 1 is the only other odd number here that is not prime, sorry. And 9 is also odd but not prime. And then we have the only number that is prime is 2. 2 is the only prime number that isn't odd. And then the rest of the numbers have to go somewhere because they're still part of the set, and they just go on the outside. So on the outside, I'm going to put my values of 4, 6, 8, and 10. And what we can see there is we now have all our values inside our Venn diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We filled in our Venn diagram. Now, if I was to ask you a very simple question saying, what is the probability of choosing an odd number? The answer is how many numbers are inside this circle. It's not adding them all up. In this, we are saying there are 5 odd numbers out of 10 total numbers. The probability of getting an odd number is a half. If I said, what's the probability of getting a prime number? Well, that would be 1, 2, 3, 4 out of 10, because there are 4 prime numbers out of 10 total numbers. And then finally, if I said the probability of getting only a prime number, well, the only prime number here is 2. So there's only one possible prime number out of the total 10 elements. And that's what we're doing here. That's the key thing to understand, that we have our notation over here. We have over here our values we substituted in, and when working out probability, you use the fact that it's the number of elements in the specific region you're looking at out of the total number inside of the Venn diagram. It's not necessarily you have to add them. Instead, it's looking at how many possible ways there are of getting these. Anyway, I hope that's made sense. If it hasn't, please leave a comment below or please message me directly. Take care. Thank you very much.